Welcome, everyone. This is the latest in our Talking Trust video series, and with me today is Arash. Arash, I know you're calling in from a long way away, I believe Canberra, Australia, for this call. So I just want to say how much I appreciate that, and it's early morning for you, so I hope you've had enough coffee to get through our webinar today.
Hey Blair, yeah, morning. Thanks for having me. I did have my cup of coffee. It was a few hours ago. I probably need another one, but I think I've got just enough right to get me going to this presentation today. So yeah, thanks for having me. It'll be a great chat.
Well, good. Well, we're looking forward to it. As I said, this is our Talking Trust video series, and today we're talking with ConsenSys. And Arash, I understand you've been with the company for a few years, and I just want to make sure I have it correct, but you are the protocol engineering lead for ConsenSys.
Yes, I'm one of the product managers at ConsenSys. I've been with them for nearly about 3 years, and I've been kind of in the blockchain space for a little bit longer than that. It's a fascinating space, and it moves very, very fast and has been rapidly developing and growing and changing, which is very, very exciting, but sometimes really hard to keep up with. And I'm sure, no doubt, you're aware of there's a lot of things going on in the blockchain space and the cryptocurrency market. So it's becoming it's been a big hype, and continues to be, I think. As it continues to mature and grow, the technology, the cat's out of the bag, so to speak, and it's not going back in, and everyone's starting to pop their heads up and really take notice, which is really exciting.
Well, good. Well, I should have mentioned I run the business development blockchain relationship with ConsenSys, and I'm part of Talus. If I didn't say it at the beginning, I meant to. But we've been working together, you and I, and our companies for the last few months, putting together what we believe to be a pretty exciting combination of technologies. And what I think we could do is, no one's looking forward to about 30 or 40 slides. So we can assure you that if you listen in, this is only going to be a few short slides. I'm excited because I know you, as much as I do, don't like those long type of deep dives. So we're going to go at a very high level, explain a little bit about our two technologies coming together. And again, what I would like to do is give you the opportunity to talk about ConsenSys, talk about the Ethereum aspect of what you're doing. And if you could pull up the slides, we'll do so. We'll get through the slides, and then we'll come back at the end to do some wrap up.
Great, sounds good. So I might jump straight in and start talking a little bit about all the exciting work that ConsenSys and Talus have been doing together. But just to kind of level set and make sure we're all on the same page, I find it useful just to very, very briefly touch on what my definition of blockchain is, right? And our viewers could be someone that's very, very familiar with the concepts of blockchain and blockchain technology, or some that this is a little bit more new. So just at a high level, what does a blockchain mean, right? So, and there's two kind of words in that. So there is this concept of blocks that I'll touch on in a second, and these chains. You can think of a blockchain network as really a ledger of transactions, right? So a ledger of transactions of who sent what to whom on what date. And that might seem like a very common concept that we're very used to, with things like databases, for example. And the distinction with the blockchain technology is that it's distributed and decentralized. And what that means is that everyone has a copy of the data. So Blair, if you and I are on a blockchain network,
right,
we both have a copy of that database, right? So in a traditional sense, you might hold the copy of that database, and you gave me access, and I can access your database. But there's no way for me to really know if you go behind my back and change anything on the database. When I have a copy of that, if yours looks different to mine, then it's very clear. And when things are distributed, then we both kind of share ownership over maintaining that database and making sure it's robust and secure. And these concepts of blocks, where they come in, is what you can imagine is a blockchain is a set of transactions that take place on the network. So I send you $5 on this particular date, and all these transactions that take place get put into a box. And these boxes get sent around the network, and they stack up on top of each other. So these blocks stack on top of each other. So block 1, then 2, then 3, then 4 in sequential order, and that's what forms this chain concept. And I guess the key differentiator and the value add that blockchain networks provide is to be able to guarantee the authenticity of who produced these blocks. And what we're going to talk a little bit more about here today are these cryptographic keys. So we use these keys to sign our transactions and sign our blocks to validate that this block was produced by me, and I am sending you this block, and I own it. So these keys are what we want to really secure and make sure there's control over, because losing our keys and losing our identity can essentially is what compromises the network. And we'll talk about that a little bit more. So the key thing that we want to do with these cryptographic keys is make sure that they are robust and safely secured, because if someone gets access to our keys, then they can imitate us on our network, and they can pretend to be me on the network. So although blockchain technology itself is tamper-proof, losing your keys, then that's where trouble comes in. So I was listening, for example, to this podcast the other day about a heist on the most secure vault in the world. I think it was back in the 90s or something. And the vault had all the security measures in place that it needed. And one of the security measures was this 2-key system, so that you actually needed 2 physical keys that could be detached and stored separately to access the vault. But what the burglars realize is, that the security guards, just for ease, they kept those 2 keys together in the room right next door to the vault. So you can, produce the more secure vault that you want, but if you don't keep your keys secure, locked away somewhere, then it's very, very easy to hack into, right? So lots of lessons learned over the years.
Yeah, I don't think that they were too clever about their separation of duties in that example. But we'll talk as well on the HSM side how we could make that problem go away quite easily.
Yeah, exactly. So now we've kind of talked about, what is a blockchain network? I guess the next question that we usually get asked is, why is this important? How big is this space really? I mean, if we're talking about, hundreds of dollars being, run on a blockchain network, or even potentially thousands, and the remote possibility of a hack, how big of an impact can it really be? And I guess what I wanted to, bring to everyone's attention is really how big this market is and how rapidly it's growing. And what I want to talk about here is just very briefly the growth of the enterprise market. So when we're talking about the Ethereum, let's just take one blockchain example, and at ConsenSys, we believe in the value of Ethereum as the kind of biggest blockchain network with the most number of active users and developers in the space. And excluding kind of the mainnet network, which is the permissionless network that anybody can join and transact on. And, there's billions of dollars secured on that at the moment. But even putting that aside and looking just at the growth of the enterprise adoption, there's nearly $7 billion in value that they're projecting to be used in the system, within 2021. And the growth of number of kind of Fortune 500 companies that we've seen coming into space and moving their projects from what they term, proof of concept and R&D development projects that had started a number of years ago to real production value add with end user access is really rapidly increasing. And you can see this across.
And Arash, we talked a bit about this previous to the call today, but it's really an element of the maturity of blockchain as you see it. So what you're saying here is that a great deal of the transactional value of 7 billion pales in comparison to the traditional markets, but you're seeing as an emerging technology, the trust and integrity is becoming an issue. And with what you're just describing today is, if people trust it, they will use it. Is that a fair statement?
Yeah, 100%, exactly. So trust and integrity of a blockchain network is very paramount. And as one of the fundamental elements that blockchain tries to bring in is this concept of distributed trust, right? So it's a trustless technology because you can trust in the protocol and the system rather than necessarily trusting, the person that you're interacting with. So
Right.
having that trust in the integrity of the solution is paramount, because if you don't have that, then what else is there? It's really, the market is rapidly growing, and I think it's moving from a stage of a number of technologists really using these solutions to mainstream adoption, and we're really seeing that pick up over the last few years.
Well, today we'd like to talk about that in the application side, in the moving from theory to practice. So maybe you could talk a little bit about how ConsenSys Quorum is a product that is both unique, but also adopting and adapting and providing those trust elements that you described in your previous slide. So I'll let you walk through this slide for us a little bit.
Yeah, sure. So just at a high level, touching on what ConsenSys Quorum is. So ConsenSys Quorum is an open source blockchain platform that you can use, as I said, for a permissioned or permissionless network. So it supports a permissionless network, that a public chain that anybody can use. But what we've also seen is a wide range of adoptions across different use cases for permission chains. So consortium chains that are coming together to transact and have solve some particular use case. So we've seen this from financial use case predominantly to reduce the cost of operation in supply chain for tracking food, for example. And you can kind of build any sort of platform that you want on top of ConsenSys Quorum. So ConsenSys Quorum provides that base layer application, which is the trust of the distributed technology and running the blockchain network for you. And there's a lot of, a number of kind of features and things that it brings to place, both in permission network, where, things like private transactions and privacy and security is quite paramount. So you might have a number of organizations that are transacting with each other on the network, but some of those transactions need to be private. So it supports that. As well as allowing permissioned access, so who is joining your network and what kind of transactions are taking place, and this kind of signing capability, which we're going to dig into a little bit more about, providing keys and security, storing those keys separately to your application layer, so you can provide that differentiation. But ConsenSys Quorum is a really customizable solution that you can pick up as an open source tool and start developing your application on it straight away.
Great. I think that's a great segue into the next slide. We're going to talk a little bit about the key security elemental to the integrity of the entire blockchain. So, as we put the slide up here, and to the right we show a typical HSM, maybe you could talk a little bit about your perspective on the attack vectors and what that could mean to a blockchain environment and why it's important to protect that infrastructure. So carry on.
Yeah, definitely. So I guess as I keep talking about these keys, one of the paramount things that we identified when we're building solutions for our customers is, how do you store these keys? So where do you put these keys to provide a level of integrity and access that's required, but also make sure they are in a tamper-proof kind of sealed environment that can't be accessed. So just the integration that we did with Thales was essentially an integration with ConsenSys Quorum and a Lunar Network HSM module, which allows for these keys to be stored securely in a separate device, an off-chain device. And that integration allows ConsenSys Quorum to communicate with an HSM module for any transactions and processes that need access to the HSM. So your keys are actually never leave the HSM application. And I'll talk in a second on the next slide about what you do with these keys. But as I said, paramount to this is being able to differentiate and securely keep your keys away from your server layer, so to speak, where your application resides. Because in the event that somebody gets access to your server environment where your application logic is, at least if your keys are separated to that they can't get, even though they might get access to the data, they can't imitate you on the network and pretend to be you and therefore access your funds. So digging in a little bit about how we utilize our integration with the Lunar HSM module. It's really about proving your identity on your network. And in an Ethereum blockchain network, your identity allows you to do a number of things. So when you peer with others, as I said, it's a distributed technology where we communicate and shake hands when we, with each other. We identify who we are. So just in real life, when we meet one another, I say, "Hi, Blair, I'm Arash," and you just trust me that that's my name, that's my identity. And in a blockchain network, you use these keys to identify who you are when you meet other people on the network. And one of the other things you do once you peer with other people, as I said, when you do these transactions and create these blocks and sign your name on the block and send them across, is when you create these blocks, you sign your name on it, right? So using your key, you sign the block that says, "Hey, I produced this block. Here's my copy of it. You validate it against blocks that you have, and make sure they're identical, that we're both speaking the same language." So that again is a critical component. Maintaining the governance of the network is also important. So in a permission chain, these nodes, which are essentially the computers on the network that run this application, that maintain the network, get to also say who is and isn't in a permission network, right? So if you and I control the network and somebody else wants to join, I have to say yes, they can join, and you have to say yes, they can join. So you can imagine what would happen if someone was imitating my identity, then they could obviously let others join the network where we don't necessarily want them to. So all these kind of controls that are in place, you can see how important it is to make sure your cryptographic keys are securely stored away. And the value that we have with the Lunar HSM module is that we can create the keys in the HSM module, they can stay in there, and they don't ever have to leave the HSM module. So when we want to create a block, we go and talk to the HSM and say, "Hey, I want to create a block. Can you use my key to sign this for me?" And the Lunar HSM module does that and send the signature back. So we know that the keys never leave the module itself, and any communication we need to do, we do directly and send back.
And I think the key here is that it's not optional. It's not an exception. It's a rule. And what you've built here is the integrity of that design mandates that every single transaction, as you've described, has a root of trust in that cryptographic module. So I think that's a key element, no pun intended, that we find ourselves in, is that this being a transparent operation from a usability point of view is one of the value benefits, is that this is all running in the background. This is plumbing and wiring, and the performance is not affected in any shape or form. So we're really glad that we're working with you to make this truly a win-win-win situation by using the elements within ConsenSys and the value proposition of HSM technologies. So we've got a couple more slides here. Did you want to walk us through perhaps maybe some of the resources that are available to our listeners today, and what they could learn by going to your website or some of the documents there?
Yeah, thanks, Blair. Yeah, definitely. So there's obviously tons of material available out there if you want to learn more about both Thales and as well as ConsenSys Quorum and what we do, and our integration with the Lunar HSM module. So please reach out. Our contact details are there if you want to talk a little bit more and dig into some of the more technicalities. We're more than happy to do that. But as I said, we found that this is a kind of key component for networks that are moving to production. So while we're in kind of POC and testing phase, those kind of security elements don't necessarily come into it. They're not top of mind, and the application logic seems to be top of mind for most of our customers. But as projects move through pre-production and getting into production, the Luna and essentially HSM requirements are paramount. And as you said, they're definitely a hard requirement. So any customer that we speak to definitely has those requirements, and this is part of the stack that we've worked together. So please reach out if you have any questions, and happy to talk a little bit more about this.
Great, and as I've said, we've got the data sheet elements available, and from a resource point of view on the slide there, you can reach out to myself or Arash if you have any questions. I'm just going to end the slides here and put our talking heads back up on the screen if people have forgotten what we might look like or sound like. Arash, I just wanted to say thanks very much. We're very excited to be working with ConsenSys, and appreciate you walking us through the technology stack. If there's anything that you'd like to add at a later date, by all means. We're looking forward to working with you and evolving as your technology evolves with us. So thanks again for all of your input, working with us on the TalkingTrust webinar series. And again, we look forward to working with you.
It's been fun. Thanks, Blair. Thanks for having me.
You're welcome.